purpose of this work is to mainly give you a starting point. So if this is a little bit more elementary, I'm hope that you still find it interesting. Um, Before I dive in, my name is Roya, and it means a very sweet dream in Farsi. So I tend to make the joke that my parents thought I'm their sweetest dream, but they realized I'm their worst nightmare. So they shipped me across the globe. So I'm far enough from them. And my mom recently heard it, and she's like, no, absolutely not. But I have to give that disclaimer now. I got my PhD in electrical engineering under the supervision of Professor Kamishna Maduri, and he's a well-known scientist for his work on unmanned airborne vehicle. I'm working as a research scientist in generative AI, and aside from that, my evenings are to develop the community and enhance AI literacy. So I'm a Google developer expert. I don't work for Google. I work with them to enhance AI literacy in the community. I'm a woman tech maker ambassador. That's also a program by Google to promote women and non-binary individuals in their work and in their education. And lastly, I'm a community builder. So I guess some of you are based in Boston. We would love to have you over in some of our in-person events. I want to thank Google for letting me do this. And with that being said, I would like to give you a little bit of background about what is generative AI and how we got to where we are. And later I will walk you through something that I found interesting, which is a sandbox Google provides to its user. And we end this session with a hands-on workshop. I will give you the code and hopefully you will be able to work on it on your own time after this session and build something new. And I would be so happy if you share it with me and if I could help you to actually publish it. So first thing first, what is generative AI? And I would like to ask you, how many of you heard about generative AI before the volume of ChatGPT? So before, let's say in 2022, if I can have a raise of hand because I see some of you here. I see. Um, and this is exactly why AI had this hype around this. So I want to walk you down the lane of history and we talk about 1960s, the beginning of the AI and when people decided to build this machine that are able to make decision on their own. The initial idea was that if we give this machine enough of resources, they should be able to make decision independently. Prior to what we see today as a modern AI, the idea was to build enough of laws and rules and conditions for the system to make the right decision. I give you an example. Suppose you are building a machine and its job is to determine whether there is a cat in this picture or there is a dog in this picture. You are thinking about all of the characteristics that would define a cat, whereas a dog. So something really easy like usually cats have pointy ears and dogs have fallen ears. So you need to code it, which is harder because you need to detect their ear and then you need to code the ear. In addition to that, if one of the ears are covered, then your system would not work. And then you have corner cases to think about, like, for example, a dog like a husky, they have pointy ears. So how would you find that answer? But still, it was a very viable solution because I guess some of you might remember around early 2000s, Sony, the digital camera, started to be able to detect faces and snap a photo when they would detect a smile. That was something that I always dreamed of having because I was so young and never had. So I remember it perfectly. But the way that they did it was to identify what is the average a smile look like, and they would snap a photo seeing that, which to the point that I made earlier, given that all of the smile would not fall into this average region, we would be missing something. So, for example, people of certain origin and nationality, they would always be penalized because their smile wouldn't be seen or their eyes wouldn't seen as open. In 2012, I have to name drop this person because I admire her so much. Dr. Fei Li utilized all of her PhD grant, not sorry, all of her faculty grant as a tenure to build this very large image data set called ImageNet. and have people hand annotate this data set. To understand the significance of these data set, think about that all of the major data set prior to that point were only 10 objects, but she started these 1,000 categories data set, which each of them had about at least 100 essentially representation in that data set. So we are talking about millions of images. So she had it hand annotated, and to have people actually start utilizing it, she started this competition called ImageNet. So we had the data, but there is something else happened at the same time. NVIDIA started open sourcing CUDA and enabling commercial level access to high compute like GPUs. So regular people, by that I mean non-military people, were able to connect multiple GPUs to build compute for doing significant things. GPUs were originally built for gaming, but now people were using them for answering to very complicated mathematical questions that required matrix multiplications. So these two coincide at the same time, enabling University of Toronto and Geoffrey Hinton lab to build essentially the first AI model that was able to detect all of these categories, so classify all of these images with significantly higher accuracy than anybody else. I need to be clear that the algorithm that was used at this competition was actually an older algorithm, but having the coincide of the right algorithm, the right compute, and the right amount of data enabled them to build this one model. So 2012, we had this breakthrough, and since then, we are able to generate better models. So doing a cat versus dog, which was quite a challenge 20 years ago, now it's something that we teach at the early basic levels of AI. But now we are in 2025. We are significantly better with compute, and we have way more data than what we had before. Data sets like ImageNet are now so accessible to us. What it provides to us now is that we can go for bigger and larger models, and larger models tend to hold into more information. So rather than having models that are only able to determine the object, for example, in a picture, they are able to recreate an entity that would hold all of those features that make that entity a specific thing. So if it's a cat or a dog, it's able to build them from scratch. So just to summarize, we are making data more accessible, and we are having more access to compute. So for example, the model that was trained for 2 weeks in 2012, right now is less than 5 minutes. And it enabled us to train larger models that are able to do bigger things. And that's generative AI. So if you train these models with images, you will have image generative model. If you do train them with text, you have large language models. Large language models are essentially fancy autocomplete, and they are a statistical model that are able to find the right next best word. They do it just by being exposed to billions and billions and billions of data points, billions of sentences, and essentially context in internet and in literature. And simply because they have seen it so many times, they have this statistical model of, okay, what is the percentage of dogs completing this sentence if it starts with "it's raining cats and." It still considers the possibility of the next word being rain, for example, with 3% accuracy. But if we design it to choose, for example, the next word with the highest accuracy, it would go with dogs. And then the next time that the model would be inputted with "it's raining cats and dogs," and the model determines what is the next best word. If we hit to a point that there is nothing good enough, then the model stops. Sometimes we reach to the context window of the model, and the model simply stops creating more. So if we have roses are red, then the model is able to create violets are blue and sugar is sweet. But bear in mind that it generates them one token at a time. And token is essentially the smallest unit that the model understands. And it's just to make the system more efficient because otherwise you had to do, for example, wireless, that this works correctly. But right now, with a few lines of code, you are able to check at least and verify your idea whether we can have an LLM that is able to identify the PHI and PII and retract them. And it happens because they are large and they are generic, so they are able to do many, many tasks simply because they know the language very well. This is also the point that I wanted to explain that these models are not factual inherently. These are a statistical model. They don't know if the answer is right. So your chance of getting the right answer is as good as the internet. If the internet is messy, these models are not able to give you a right answer. And if internet gives you a biased answer, these models tend to actually provide you with that biased answer. Before we dive in deeper into large language models, I want you to look into classical natural language processing because um, it's not fair to everybody who was working in natural language processing before to think that all of the good thing happens because of large language model. We had so many of the attributes of large language models, so many of the applications of large language model built already before. We had entity extraction, we had sentiment analysis, we had translation. My mother tongue is Persian, so I've been always using Google Translate to understand and to make sure that I can communicate easily with others who are coming from different languages. And it happened way before the time of large language model. Google Translate been there for, I think, at least a decade. Or Twitter, which I will not call it the other word. Twitter has been always doing sentiment analysis because if a tweet was, for example, containing hatred or content that was not comfortable for everybody, it was able to identify it and pull it down so quickly. Or we could easily identify whether a Google review is positive or negative doing classification. So what does large language model provide to us? Aside from the fact that these large language models are able to make sense of words, so they can see into something that is essentially a prompt, so a smaller tone, and make sense of what it is, they are able to give us more room for searching. And I would say that's a byproduct of the large language model because search happens through the way we create numeric representation for words. And because now we have these encoded arrays of numbers that each of them represent a word, we are able to mathematically calculate the distance between two words. I don't know if you have heard about man, woman, and king and queen. Is there anybody who knows about that diagram of man, woman? No? Okay. So I think this might be fun for you. Everything for any type of natural language processing happens because we can decode words into numbers. We can decide what series of numbers would exactly showcase a certain word, right? So think about a word in which we only have two axes. One of these, I think the right word is axis. So forgive my rusty English. I've been talking it for 10 years, but it's still something I'm not sure what is the right word. But anyhow, so one axis shows um, being a man versus being a woman. So there is a spectrum. And the other axis is being an ordinary person, whereas being a king. So I show one of them in the vertical axis and the other one on the horizontal axis. So in 0, 0, the place of the 0, 0, so I think it would be here for you. I don't know if you see my right and left correctly or not, but imagine on the place of 0, 0, we have woman and ordinary, so that would be just a woman. So if we increase the location of that woman, if we change it to more kingness, more royalty, then we will get a queen, right? And then if we change the location more toward being a man, then we would get a man. And if we increase in both direction, we will have a king. So somewhere in the middle, for example, in the royalty lane, we would have a princess. If we move upward from a woman or from a man, we would have a prince or princess. This is only if we have 0, 0 for a woman, 0, 1 for a man, 1, 1 for a king, and 1, 0 for a woman, for a queen. You see that there is a very tiny numeric representation for only these four words. In reality, and I hope the way that I put these numbers were quite random. I just like built it in my mind. Please don't extract anything that I'm crazy or like these are I didn't mean to say anything wrong about any genders, anything. So I love all of the genders. Thank you. Uh, so, and all the spectrum, everything in the between or beyond. Um, Back to my point. In reality, we have between 500 to 700 and over numbers. So instead of just two, we have 700 numbers to represent a word. And it enables us to calculate what is the distance between two words. So the word for good and the word for nice would have similar location in this quote unquote latent space. That is that multidimensional space. Here, when we were talking about women, men, we had a 2D space, a two-dimensional space. So imagine a space with 700 dimensions that enables us to build these words. And now we have this numeric representation, and this numeric representation enables us to calculate because instead of words, we are dealing with numbers. So we can quickly figure out numbers. Hence, we can do quick search. So rather than figuring out, okay, I have the word for good, and now somebody has to figure out from the dictionary, what is this bag that I can put all of these other words that means something good? We are just calculating the distance between the numeric representation for the word good and everything else. And then we calculate which ones are in the same vicinity. So if Roya doesn't know what are all of the synonyms of good, and she writes something in Google and tries to Google something, but it is not the right expression to Google, I get the right expression calculated because Google sees all of those numbers. It doesn't see the words anymore. So we get a very better experience of searching rather than what we had previously, which was a bag of words. So somebody had to hand annotate all of the words that are close to each other. Second one is the idea of conversation. Be very clear, it is not what is happening within the large language model. It's something that we are creating around this. We are building a system to make this illusion that the model knows, the model can follow a conversation. But in reality, we are feeding the model this new information again and again. So every time the model says something to you, the engineer who created that chatbot holds a snapshot of that thing that you said and what the model responded to you and feeds it back to the model. So the model can follow an illusion of conversation. And lastly, I think is the most obvious one, which is content generation, which as I showed before, when you are asking the model what a joke means, because it's been exposed to many examples, it can make sense of what that joke means and create output. I know that this is a huge tangent, but I need to explain this too. Jokes are hard for model to create, so they are able to explain them, but they cannot create them because this model are creating words sequentially, so one after the other. And jokes require you to know from the get-go what is the ending. So these models are not good at creating new jokes because they are generating one word at a time. They are not planning for what is happening next. But building, for example, poem is easy because they can keep the rhyme one word at a time. If you are interested, there is this other method called diffusion models that they actually build the whole sentence at the same time. And they are our best bet for creating AI generated jokes. Okay. I took the time to explain to you what a vector for word means because I wanted you to appreciate as much as I do what multimodality means. All of us have, I don't know if you looked at least like into Google I/O, but I appreciated it so much because you could type something and it would create a video with voice for you, or you can record something and the model is able to at the real time answer to you, which has significant assistive technologies in it. It can help so many people, and I'm so grateful for that. The way that it happened is simply because now you have all of those numeric representation. And building numeric representation for words is the hardest of the four major modalities. The four major modality are essentially text, audio, video, and images. And the other three, we already had numeric representation for. We can digitize everything. So we can digitize images, audio, and video, and it was harder only to digitize words that now we have a really good way of doing. So given this, we are able to not only calculate the numeric distance or mathematical distance between two vectors of numbers, we can force the vectors that represent the same concept in different modality to stay in the same vicinity. When we are thinking as humans, and we are thinking about something, let's say the word Paris, everything about the word Paris comes to our mind at the same time. We don't need to think about them separately and reach into different parts of our brain to think how Paris is written or how it is said, or thinking about the Eiffel Tower or the smell of a good baguette. All of these senses, all of these different modalities are in the same vicinity in our brain. And this is the same concept. So in that latent space, which is that multidimensional space that we are defining words, we can define images and ask them to stay in the same location. This idea was first introduced, if I'm not mistaken, by the one and only Andrei Karpathy, who created image captioning for images and made sure that the caption and the image are staying in the same vicinity in a latent space. And Google shows it in three major models, the Ultra, the Pro, and the Nano. The Ultra is the bigger model that now if you want to have access to it is $200 per month, which is way outside of my budget. Pro is accessible to everybody, and Nano is if you are a developer and you want to have the model on your phone. So now with that being said, and I talked a lot, I think, I want to show you how to actually start using it. So if you are on your laptop, I suggest you leave this screen, but still hear to my voice, and go to aistudio.google.com. It's a sandbox essentially by Google that enables you to play with some of its model without actually incurring any charges. If you are extracting this model outside of this sandbox and you are actually making calls to this model outside of this sandbox, you will be getting charged. But there is a feature here within this sandbox that enables you to just play with this model. And I also stop sharing and then switch to the screen that actually has those. If I can just switch. Okay. So this is, can somebody give me a thumbs up if you are saying welcome to AI Studio on the screen?
Yeah.
Perfect. Thank you so much. Okay. So this is your AI Studio, and let me get rid of this thing here. Okay. So you have chat, and then in the middle, you have essentially anything as a chatbot. So it is similar to Gemini, this is similar to ChatGPT or anything else, and you can type in the middle. You can stream. Sorry, did somebody have any question? I didn't understand. You good?
Yeah, it might just have been background. Yeah.
Okay, perfect. You have generate media, so you can utilize video, or you can utilize Lyra, which is the model to create music, or you can utilize Imagen to create your images. You have There is a background voice. If you can just put yourself in mute,
Mute,
I'd
yeah.
really appreciate it. On the top, you have get API key, and we will talk about it later on. But in general, this is uh, a key that enables you to utilize these models outside. And if you do not have one, you can create an API key, connect it to one of your Google projects, and then hit the create, and it actually stays in here. So different from what OpenAI and other providers are doing, you can access to the same API key later on. Let's go back to the dashboard. On the side, you can choose which model you want to use. You have access to Gemini Flash, Gemini 2.5, Gemini 2.0, which has the Flash models, Gemini 1.5, and Gemma models, which is the open source model. And then you also have access to some of the other LLMs. Let's have some sort of basic prompting. Let's do create a poem about a girl's hackathon. And then we run it. And it takes a few minutes. Okay, I did not choose the right model because this is the most expensive thinking model. I should have chosen something else. While it's thinking, let me show you a few other points. In the middle, you see that there is input and output API pricing. So if the number of tokens that you are utilizing is less than 200,000, each time you are paying $1.25. And for each output, you are paying $10. To be clear, this is not about here. This is when you are using it outside of here with your API key. And this happens for every 1 million tokens. So it is not for every time that you hit 200,000 tokens, but if you have like 5 calls that each of them is 200,000 tokens, then you are paying $1.25.
So you're
And
saying,
obviously,
sorry, Roya, if you don't mind, like me interrupting.
Mhm.
Yeah. You're saying this is if you were to integrate the studio with some other software? Like if I write an
Correct.
application and okay, I'd get charged. Yeah.
Yes. We have the free tiers here. But when you are leaving this space, you are not using the free tier. But here you cannot actually, this is essentially you can use it as much as if you are just like using ChatGPT. Take it with a grain of salt because I have pro access. I'm not, I don't want, and I'm not really good with money, but as far as I know, and I asked Google, it should be free in here. And then the output. So did I answer your question?
Yeah, no. I mean, again, and we just to confirm, like basically, if you're using it within the studio itself, I don't think you'll get charged. But if you're integrating with an external software application,
Correct.
yeah.
Exactly. But I don't mean to scare you because you have like the Flash models and they are way cheaper.
Mhm.
So let me actually explain it here. So for example, in a thinking model, you are paying 15 cents and then the output would be $3. If you don't do thinking, the input is 15 cents, the output would be 60 cents. I wanted to explain two different concepts here. One is the idea of thinking whereas non-thinking. When you are having a thinking model, it means that the model would create an output and then the output would be inputted to the model and the model would rethink in quotation because these models don't think, they are just trying to make better sense of what is happening. And then it does it multiple times. So your output would be more expensive. Whereas if you are choosing a non-thinking model, and in addition to that, when you do a input versus output for the same number of token, if your output is always more expensive. And it's because of the compute that you are utilizing. When you are creating the input, you can create the input in a parallel manner. So you can merge or couple more GPUs together to transfer your input, your textual input to numeric values. But as I mentioned, these models are sequential, so they create one output at a time. So there is no easy way to create your output in a parallel manner. So more resources is utilized, more time is utilized, hence you are paying way more money. There are three more items that I think is of importance to you. One of them is if you look into the bottom of these pop-up, which I cannot move my cursor because it will go away, it says knowledge cutoff. Knowledge cutoff is the moment that Google, in this case Google, collected all of the information it required and then trained the model, and then the model has no information after that point. So if you want to utilize this model and ask it for anything that happened after January 2025, this is not the right model. You need to provide it with more information for the model to be able to answer to you. And then in the other side, you have latency, and the latency of different model is significantly different. So if you are tending to do an application that requires closer to real-time response, you wanted to be very aware of the latency. So, and now we see that we actually have a poem. So it says, I just will read the first four verse of it. So the doors swing wide, a vibrant hum, the future here, the coder come, laptop gleam, a hopeful sight, bathed in the screen electric light. And I think that's quite interesting. Uh, I'm doing basic prompting here, but something else that you can do to this model. Do you still see the AI Studio or did your screen switch?
Your presentation. Yeah.
Okay, perfect. So I show you how to do the basic prompting, but something else is you want to bring your own data simply because the cutoff that I mentioned limits you and you are not able to answer the question after the cutoff time. Or you are working with private data, for example, if you are in an enterprise, you do not want to expose your data to this system. In those scenarios, you are providing these models with your own data that they can serve as instruction, context, or ways to implement things. And it's interesting to know that at least when these slides were created, Google was by far the pioneer. Right now, Meta with 10 million context window is the pioneer. But the majority of the providers stay within 128K to 200K. But Google with the model with 2 million context window is able to analyze and respond to you about any question for a 2 hours video or 22 hours audio. For those of you who are working in companies with legacy code, 60,000 lines of code would fit in one prompt. And lastly, if you were a Harry Potter fan, all 7 books of Harry Potter combined is 1.1 million words. But if you have 2 million context window, you can fit up to 1.4 million words. If you are building this for production, there are ways to calculate the number of tokens prior to feeding it to the model, which I strongly recommend you doing that. Otherwise, you are paying for the API, but essentially you are waiting, but there is no response. And me being a scientist, I cannot escape talk about context window and not talk about this one paper. Attention is all you need. There's a paper by Google, and it was published in 2017, which is the backbone of everything that you are seeing in large language model. It essentially utilizes the same concept of man, woman, king, and queen, and it makes sure that in addition to what is actually available, so in the grade, we are utilizing words to make sense of other words. So imagine we have a grade that one side of it is fruits, fruitiness, and the other side of it is technology. We have strawberry and orange in one side, and we have phone and Microsoft in the other side. So if you have cherries, you expect it to go and sit with other cherries. And if you have Android, you expect it to go and sit with other uh, technologies. I said cherries will go with other cherries. I meant cherries go with other fruits. But what if you have something like Apple? It can be a fruit and it can be a technology. What we want is to apple that mean a fruit, the apple that means a fruit to sit with other fruits, and the apple that means a technology to sit with other technologies. But in reality, they sit somewhere in between because they is essentially when you are training this model, there are enough of cases that the apple is a fruit and enough of cases the apple is a technology, so it will wiggle something in between. But when we do use attention, we are making sense of each word based on the word around it. So if I say, please buy an apple, in a very beautiful word, maybe the person that I asked them, go and buy me an iPhone. But in reality, it is less likely. However, if I say, please buy an apple and an orange, simply because of the word orange, it's obvious that the apple means another fruit. And when we say Apple released a new phone, because of the word phone, we know the apple is technology. So using this information, we can create this gravity from orange toward the fruit apple and from phone to the fruit apple to the technology apple to draw them away from each other. And that's how attention works. And that's how we have a context window. And that's how LLMs work. LLMs also do image understanding. So if, for example, you give it these two emojis and ask it what is the name of the movie, I think you all can guess that's the Charlie's and the Chocolate Factory. Or for example, for this one, it would do Home Alone. And lastly, if you ask for this book, you can guess that it's The Secret Garden and an A Space Odyssey. Before I totally switch into the AI studio, I want to raise awareness to responsible AI. As I mentioned, these models are trained on the content of internet, and the content of internet is not particularly uh, something that we can be proud of all of its content. So our biases and some of the not nice things exist there. Hence, when we are training on these models, um, aside from making sure the training data is clean and clear and as much as possible free from bias, we also have this wrapper around these models to make sure that there are guardrails and these models are not gonna just create anything. Something that Google and all of the other providers do is when they are providing you with this model, they give you knobs to tune how much of these content you are tolerant towards. So if you want to absolutely cut off all of these type of content, for example, if you are creating application for minors, you have these knobs to tune to make sure there is no toxic content or as such. With all of that being said, I invite you to get this. Let me put it in the chat. Go to this GitHub repo and let's work on it together. And let me find where I can put it into the chat. I put the repo in here for you too. And while you are cloning that repo, I go back to the AI Studio to talk about a few more things. If you do use, do you see my AI Studio? Perfect. There is a thinking budget right now that you can set so the model will not just go into this semi-infinite loop of just thinking, and quickly rack up your budget. And you can say how many tokens from your output you are willing to spend on it. And bear in mind that we had a bigger charge to pay for the output tokens. You have a structured output, and that means that you can create the output in usually in a JSON format. And that has been quite a challenge for these models because it's hard to make sure they are creating the right output. But here, Google, and as far as I know, OpenAI do the same thing. You can create a schema for the JSON that you want, and the model would create something exactly in this format. You have code execution that enables the model to actually create a code and execute it to reach to the best answer. You have function calling. Function calling is when you want to get the output of the model and feed it to a different function, suppose a weather function, or I don't know, if you, for example, want to calculate the a stock price right now, and then it creates for you. You need to define what is the function, what is the description of the function, and what type of object you want. So in reality, we actually have an API that would gives us the temperature if you give it the city. So you can make sure the model generates an output that is exactly the name of the city. You utilize it, you pass it to the model, and then get the output of that model, feed it back to the LLMs to create a right nice output. Google has access to all of the Google search, so it does grounding with Google search, which is when you are creating an output, it verifies it by searching in Google. If you are using it for production, I think it's $10 per API call. I don't quote me on numbers, I'm bad with money, but I think it's quite an expensive measure. And then lastly, you have the URL context, which limits it to, so then you want to provide the model with more information, more up-to-date information. If we have the safety setting, that is what we discussed previously, so you can change how much you want to block the output of the model. You have the stop sequence, and it is if this specific word is created, no matter what is the probability and confidence of the next word, I want you to stop. There is the output length. It's more on the red teaming side. So if you are using it for your specific purposes, very limited user base, don't worry about this. But if you are opening it to public, somebody can quote unquote inject prompt into your system and make sure that you are racking up costs by creating very long outputs, so you can adjust it to be tiny amounts that you think satisfies your need. And lastly is your top P, which is the probability that you expect your output to be. The closer to one it gets, you are enforcing the model to choose just the highest values. But the smaller you make it, then the model has more values to choose. Everything else would be cut down. So it's essentially a threshold. I hope by now you have the code ready so I can walk you through the code also. It's a very quick and okay, let me see. Do you see my VS Code?
Not on your screen. Seems like you're still showing AI Studio.
Let me change that again. VS Code, share. Okay, good.
Yep.
Yes,
Perfect.
now we can see.
So the first thing that you want to extract is your Vertex AI project ID. These are information that you can extract from generate code in your area studio. I don't want to like switch the screen right now, but I will show you again how you can extract information. This information would be within your area studio, or if you're a Vertex AI user, it's within your Vertex AI. I did it with my Vertex AI information. So I get my project ID. I initialize it with the location, and I have already incorporated my API, my API key. I initialize the model, and I provide it with all of the features that I discussed with you. So we discussed about the maximum number of tokens and top P value. I did not explain temperature. Temperature is what enables you to essentially make the model more creative. So you give model more leeway to choose from words with less confidence. You also have your safety settings, and that's how much hateful or dangerous content you are enabling the system to tolerate. The rest is a streamlet. I don't know if, do we have any web developer on the call?
Yes.
Okay,
I have used Streamlit here.
okay, perfect. If you are a web developer, you would laugh at me, I think, because I don't know a line of HTML. I don't know a line of CSS. So the best alternative for somebody like me to create web page is a Streamlit, which is essentially a Python package that I will install, and it enables me to build any application, any web app, and quickly deploy it. So the rest is a Streamlit. I'm configuring the page. I'm configuring what I want to be written in there. And then I generate this chat initialization, which this chat code was how we are initializing the LLM. And I keep this as a state in the Streamlit. So if you have done a Streamlit, a state is how you keep the, so these models are refreshing, and every time it renders the same state. So you are giving it a steady state if you are holding this into a session state. I know that's complicated, but if you look into the code, it's very, very easy and just like web development. And then I just built a few text box for the user to enter what they want. I stop here. What I'm trying to create is a web app that I would enter the type of food that I want, and it will give me an instruction based on the food restriction and diet that I have and how much time I have, and all of the macros to create that. So we are building this application utilizing generative AI. Actually, maybe it makes better sense if I first show you how the app looks like. Oh, so if I, for example, put taco in here and I say I'm gluten free and I don't have any food allergies, then it will quickly changes what type of carbohydrate taco has, what protein it has, and what fat content it has. And then it creates all of the ingredients, how much of each I need, and an instruction on how to actually cook it. So I can change it to some other food, for example, let's say pizza, and it does the same thing again for me. So these are two different agents. The first one creates the content, the ingredients, and the second one uses these ingredients, identifies how much of each, and then create an instruction. So back to the code. So you see that I have the same text boxes that ask about the dietary preference, the allergies, and how much time I have. I collect all of this information, and the essence of the work is here. So I will build a prompt, and the prompt is given this dietary preference and these allergies. Please list the ingredients for this food. Adjust the ingredient list to meet this preference and put them in macronutrition categories. And then I just give it a very easy structure to follow. When I create it, I will pass it to the model and I hold the response. I print the response for myself, but this is essentially you calling your LLM, which is inside this session state. So you are sending this prompt with all of this new information that the user provided to you, and you are getting the response. You do not want the whole response, so you will restrict it to get exactly the text piece that you want. And then a little bit of regex. Regex is just a way to filter text because it's way cheaper than doing it here than doing it essentially with an LLMs. And then I extract each of these values, put them in the right position. And now I call another LLM This new LLMs gets the name of the food, carbohydrate, protein, and fat list with all of those dietary restriction, allergies, and cooking times, and it creates me a list of ingredients and an instruction. And I will do the same thing again. I will strip it from all of the unwanted one, and then I would create an ingredient section and instruction section and put them in there. So stop sharing and then start sharing this other one. So this is a working application, as you see. So it is not fun. Let's do something else. Let's go to Gemini. And I already did it. So what I have done and what I invite you to do, just as a practice to make sure that this session was useful to you, I created a prompt. So I prompted Gemini and I gave it my code and I said, hey, instead of rewrite this code to turn this to an itinerary planner. And then I just copied and paste this code back into my VS code. So let me show you that piece. And I might go like 5 minutes over, so please forgive me. I meant to be respectful of your time. I am, but just 5 minutes over, maybe. So this is the code that Gemini gave me, and this is why I inviting you to do the same thing, because it makes you to actually build something that you are passionate about. So essentially the content is the same thing. It changes a little bit of my style in here. It creates its own prompt. So Gemini is really good at creating the prompt. It asks for the duration, for the interest and the budget, and then prompts the LLM to create a detailed day-to-day travel itinerary for a trip to this destination that we put in there. Trip details is the duration, interest, and budget. And then here is the instruction. For each day, provide a morning, afternoon, and evening plan. So just specific activities and so on and so forth. And then you send this prompt again to the model that we created. And the model is similar to what we had before. We extract the itinerary by stripping it and getting the text away from it. And then we are sticking it into our web page. So you want to give it a try. We do a Streamlit run trip. I have to share the right stage with you. Here. So suppose I want to go to New York and it's going to take me 2 days and I'm interested in history and 2 days. And maybe I wanted it to be mid-range and then generate an itinerary. And pray to the gods of LLM that it works. And it does. So it didn't make me embarrassed. It gives me a nice morning routine. So begin your New York adventure with a stroll through Battery Park, enjoying breathtaking views of the Statue of Liberty and the harbor. Take a ferry to Liberty Island, book tickets in advance, and so on and so forth. I invite you to do this and share it on your LinkedIn. And don't worry that if you do not have the right idea, it's a practice, but it starts you because it gives you that starting point to begin building something that you're actually passionate about. I would be more than happy to answer any question. I'm actually not over time, so I'm happy to be respectful of your time. Feel free to reach out to me on LinkedIn. I'm usually quick in responding. Sometimes life catch up to me, but overall, thank you so much for spending your evening with me.
Thank you, Roya. This was amazing. So, I mean, I didn't know anything about Gemini. I want to tell you, I was like hyped about other things like ChatGPT, whatever, but now I'll definitely go
Yeah.
look at, yeah, awesome.
Yeah,
Thank you.
it's just like what Soumya said. I didn't know Gemini was that powerful, and especially like the tokens. I didn't know that that's the highest number across all the different models we have. So this was great
Yeah.
news that the context window was so wide. That's amazing. Thank you.
Of course. Thank you so much for having me. I'm glad that you enjoyed the session.
Yeah, and thank you all, like, by the way, for joining us. I also want to say that we have some people from our partner organization, Jagati and Tracy. Um, uh, we partner with FinTech Women, and we've kind of been like supporting each other. So it's really great to see us all in one place here.
Yes, speaking for all of us, this is a fantastic. Roya, thank you, and Girl Hacks team, thank you for bringing this together. It's it really is one thing for us to keep using these generative AI tools, but seeing how quick and simple it is to build an application if you put our mind to it. You don't have to be a coder, which I think is the ethos of Girl Hacks too. It's pretty brilliant. Roya, thank you for sharing all this.
Yeah.
Thank you so much for having me. That's exactly the message that I wanted to send, that you do not need to